Okay, ladies and gentlemen, we're looking today at the 2.2 lesson plans for Math 1033, and the page that I have in front of me is asking me to determine if the function given is a linear function, and if so, it wants me to give the values for a and b so that the function f of x equals ax plus b. Now, one of the first ways to decide if something is a linear function. A linear function by definition means that the function is of degree 1. So that means when you look at the exponent of the variable, the degree should be 1. Some of you very clearly remember the formula y equals mx plus b. And if you recall in your past, when you graphed that, you came out with a line. It was the slope-intercept formula. F of x equals ax plus b is really the same formula. The only difference is instead of calling the slope m, they call the slope a. But if you recall, the slope, which in this case is a, is always in front of the x, and the y-intercept, b, is in the back. And you can't answer slope or y-intercept until you have f of x alone. So let's look at this first function. The reason this is a linear function is because the degree on the x is 1, and this is a pretty straightforward linear function. A is 2 because that is the coefficient of the x, and b is -7. So that's a pretty straightforward linear function. When I look at this next example, the reason I write a resounding no here, the reason this is not a linear function, is because you'll notice that the degree on the x is 2. That immediately kills it from being, the graph is not a line. In fact, the graph does turn out to be a parabola. You've seen that in previous units. But that is definitely not a linear function. The reason this next example that I'm pointing at is not a linear function is not allowed to have variables in the denominator. So that absolutely kills it. There's no point even looking beyond it. This example is not a linear function because, again, a linear function is not allowed to have variables under a square root. So, got to pretty much keep it looking like the form that was given. Y equals ax plus b. Can't just throw something under a radical. It loses being linear. And our final example for this question, f of x equals 17 minus 1/3 x. Well, that is a linear function. You can see the degree is 1. However, the order that it was written in was not really correct. So we put it in the correct order by writing -1/3 x in the front and the plus 17 in the back. Therefore, the slope of this line, which we write as a is equal to the number in front of the x. That's our leading coefficient, and we write that that's -1/3. And b, which really represents the y-intercept, is the number in the back. So what that last problem should have shown you is, if a function is linear, the best thing to do is to put it in the correct order. Put the x term in the front and put the constant term in the back. Okay, as we continue with section 2.2, the next question we're being asked, and I'm scrolling to it for you. You're given 3 graphs, and you're asked to determine, does the graph represent a linear function? Now, you've been taught to decide if something is a function by applying the vertical line test. Now, the honest truth is all 3 of these pictures, this one, and this one, do represent functions because each one of them passes the vertical line test. However, be very careful what this question asks. does the graph represent a linear function? So not only does the graph need to be a function, but linear means the graph needs to be a line. So the only function here below that represents a linear one is the one that I have circled. Okay? So make sure to always read the question and analyze it carefully. So anytime you see a function's linear, notice the first 4 letters in linear, L-I-N-E. A linear function would have to be the graph would have to be represented by a line. Okay, the last one I'm going to do on this video, and then I'm going to do the rest of section 2.2 on other videos. Determine whether this function could be linear. Now, I'm not going to actually do the problem for you. I didn't put this on graph paper, but I don't particularly like the approach our book takes on this. The way I teach my students to do this problem, if I want to know if a function is linear, to me, let's use the adage, a picture is worth 1,000 words. Why not get out a piece of graph paper, and why not plot these points? This is the ordered pair 0, -2, so plot it. This is the ordered pair 1, 1, plot it. This is the ordered pair 2, 4, plot it. This is the ordered pair 3, 16, please plot it. This is the ordered pair 4, 16. Best way to do this problem is to plot the points, take yourself a ruler, and see if they line up. If they line up, absolutely a linear function. If 1 or 2 points is not on a line, like in other words, if it's not going to help the other points line up, then the function is not linear. So basically, draw yourself a picture and see if you have a line.